Alright, good afternoon, gentlemen. We will go through the 2024 GA1 paper. You should have done it on your resource booklet already. And as we go through the paper, I want you to take note on how we can make links with certain questions or the words in the questions with the concept. So I think most of you have some form of foundation on the questions and some foundations on the concepts that we have. The more, I think, the difficult part for you all, or what you struggle with, is to associate the question intent, or to understand the question intent. What is the question asking you? And so how can we associate certain words or certain vocabularies that you see in the question with the concepts that you actually already know? Okay, so let's look at the first question. Mary walks barefooted across a hall with polished marble floor, and she then quickly steps onto a piece of carpet in the middle of the hall and exclaims, "The marble floor is so cold, my feet feels warm on the carpet." Why does Mary's feet feel cold on the marble floor but warm on the carpet? On the first thing, from here, if we do PRO, okay, right, our premise, okay, you can think about premise, P, or premise, the reasoning, and the outcome. The premise here, what we want to do is focus here on the premise. Premise here is that there must be some form of thermal process. Okay, then you know that there's some thermal process. And from the words that's used, you know, there is walks barefooted across the hall. So when you walk barefooted across the hall here, when you walk barefooted across the hall here, we know that there is some of contact with the floor. And we know that anything that has thermal contact, we know we are probably going to talk about conduction. Okay, so every time you see there's some form of thermal contact, two bodies in contact with each other, we know that I'm actually going to talk about conduction. So now she feels colder, right? One feels colder, one feels warmer. And we know that when someone feels something that is cold or warm, right, this has to do with rate of thermal. Okay, in the case of cold, right, when you cold means you are losing. In lower side you will say lose heat, right? But here we say rate of loss of thermal energy. So that means you lose the thermal energy. And when something feels cold, that means the rate is higher. So your reasoning now, it is that Mary actually, it's just that the rate is higher. The rate of the loss of thermal energy is higher for the marble floor than the carpet, right? So when the marble floor you lose more heat, or you lose more thermal energy on the marble floor and the carpet. It shows that it cannot be better absorber. We have agreed this. Has to be a better conductor. Okay, so the reason is that marble better conductor, right? Marble is the better conductor, better thermal conductor. Therefore your rate of heat loss, or rate of thermal energy loss, is higher. Okay, so this is why the answer is D. Next question. A rope is fixed at one end, and the other end of the rope is moved up and down to produce a wave. During this motion, what is transferred? We know that this one has to do with PRO. We know that the main premise here is we are looking at waves, right? Specifically general wave properties. And we know this is actually quite straightforward. We know that what is being transferred in a wave is that energy is always being transferred. So when waves transfer energy, but not particles, right? Not matter. Circular wave tanks are produced in the ripple tank. The diagram shows the position of the wave crest after 10 seconds. So this is what it looks like after 10 seconds. What is the frequency of the wave? Okay, so we look at this is the wave source. After 10 seconds, how many waves were created? 1, 2, 3, 4. Okay, so in a sense, 4 waves in 10 seconds. Right, so we need to go back. What is the definition of frequency? Frequency, you know, F equals to 1 over T, right? That's the formula, but the definition is the number of waves produced in 1 second. Okay, so 4 waves in 1 second. So how many waves in 1 second? How many waves? Right, so we know it's 4 divided by 10. So 0.40. Alternatively, we can think about this. Since there are 4 waves in 1 second, in 10 seconds, that means 4 period, because 1 period, remember, T is the time taken for 1 wave to make 1 oscillation, right? Or 1 wave to move 1 wavelength, right? So 4 T, that means 4 periods is 10 seconds. 1 period is 4 divided by 10. Sorry, 10 divided by 4. Sorry, 10 divided by 4 2.5 seconds. Yes, and then F is equals to 1 over T, which means 1 over 2.5. You will also get 0.4. Okay, 0.40 hertz. Can these are the 2 ways we can solve this. When a guitar is strummed, string vibrates to create a note. Which option will increase the pitch of the note? So again, the premise here, we are looking at sound, right? And we know that sound, and under sound there is pitch and amplitude. Sorry, pitch and loudness. Sorry about the movement. Pitch and loudness. Pitch is caused by, we can see pitch because of frequency, and loudness is determined by the amplitude of the wave. Okay, so this is a very important concept to have. This is a main underpinning concept. Pitch is caused by frequency, loudness is caused by amplitude. So if there is, and to increase the pitch, we need to increase the frequency. Okay, so when a component of EM spectrum is used, germicidal lamps to sterilize medical equipment. This should immediately come to you. I see the word sterilize. This should be UV. Okay, so again, I think this one is quite straightforward. Okay, this one, remember we went through, go back to the notes, the summary that we did, right? Certain words immediately associate with certain regions of the EM spectrum. Okay, now we go to the section B. In cold countries, people wear coats that are designed to reduce the rate at which thermal energy is lost from the body. The material for some coats is made of a layer of thin strips of silver colored polyester between 2 layers of fabric. Alright, the polyester strips trap small pockets of air between them. Okay, and then explain why the layer of silver colored polyester strips reduce loss of thermal energy by conduction, convection, and radiation. Okay, this is a very common type of question that you will see in your 10-year series. Okay, so important for thermal processes, you must look at words, and immediately it must go ding 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 in your head. This refers to this concept. This refers to this concept. The first one, I think everyone, let's look at the first one. In cold countries, people wear coats that are designed to reduce the rate at which thermal energy is lost from the body. Usually when we talk about coats already, this one we know that there must be some form of trapped air. And remember, when we talk about trapped air, we are going to talk about conduction. Because why? Air is a poor conductor of heat. Okay, conduction, poor conductor. Poor thermal conductor. Okay. Maybe they will give you some more. The material for some coats is made from a layer of thin strips or silver colored polyester. Now they tell you silver colored polyester between two layers of fabric as shown in figure 1.1. Silver colored. This is a color, right? It says silver colored polyester. Immediately you know that this is one of TACT. Tact. Keep going through. You must remember this TACT. TACT is temperature gradient, your surface area, your color, and your texture. As long as it goes into this TACT, we are going to talk about radiation. So here we are going to talk about radiation. This is our radiation. Okay, this where coats that traps air. This one is we are going to talk about conduction. The polyester strips trap small pockets of air between them. Small pockets of air between them. Even better, this question actually tell you what they are going to look at. Okay, so this one we know they are going to talk about conduction. Then they ask you about convection. Right. They also ask you about convection. The word is trap. Give you heart shape some more. The word is trap. Okay, the trap here, this is where we're going to talk about your convection. Okay, I'm going to use blue because the red is very jarring. Okay, so explain why the layer of silver polyester strips reduce the loss of thermal energy by conduction. Right, so conduction we already know that there is the trap air. So we are going to say that the premise is already given to you. We're going to already by conduction. So the silver colored polyester strips traps air, but that's not enough, right? This is our premise. This is the premise now that is given to us, is that we know that it's the silver colored polyester strips that traps air, but it needs to go one further. Why does silver colored polyester strips traps air? You still need to give the reasoning. The reasoning is that it is a okay, I'm going to put it down. So we know P. The reason that we're going to give is that which is a poor thermal conductor. This is our reasoning. So on top of just saying that it traps air, we know that it is a poor thermal conductor. Therefore, what is the outcome? What is the outcome of having having this poor thermal conductor, right? So that means we reduce rate, thus reducing hence the rate of thermal thus the rate of loss, the rate of thermal transfer of energy by conduction to the surroundings is reduced. Okay, so you can see the premise, we say that silver colored polyester traps air. That is the reason why we're going to say about conduction. Reasoning is that because now we know that traps air is a poor thermal conductor, and then after that you must say that the transfer of thermal energy by conduction to the surrounding is reduced. Okay, now the next one we want to talk about is on convection. So when we talk about convection, we know that we are talking about trapped air, right? So every time you see the word trap means now whenever it is gained, it is now stuck there. So another common way when you see convection is also when they talk about lids. Okay, when they use lid, why putting a cover, why putting a cap reduces? Because the convection currents cannot go. So that means now your air that is heated up, even if it's heated up, it is stuck here. It cannot go up, and then the cooler air cannot sink. This cannot happen, right? Why? Because of the it's being trapped now. Okay, so the rate of thermal transfer of energy is also reduced. Can you understand this? Okay, so the convection, why is because the trapped air prevents convection current. The trapped air prevents convection current from being formed. Then again, this is our P and R. So we need our O. So our O is, our outcome is that, hence rate of thermal transfer of energy is reduced. Okay, that's the reason why. And then the last one, radiation, we know that again, premise is the silver, right? Now we know that this should come whenever it's radiation is the easiest, right? So this should come easily to you. The premise is that silver, our premise and our reason together, that silver is a poor. Now you need to think absorber or emitter. We have to think absorber or emitter, because lost from their bodies, right? So it's lost from your bodies, so it must be emitter, right? I know the answer key put absorber, but it should be emitter. It's a poor emitter of radiant heat. Okay, or you can say poor emitter of thermal radiation. Okay, therefore less energy is, the outcome is less energy is, or less thermal energy is emitted to the surroundings. Okay, can. So thermal process questions are usually questions where you should be able to get the marks, because they are very clear, they are very straightforward. Okay, so what you need to do is to make the links of the to the concept. Okay, question 2 looks at displacement time and displacement distance graph. Immediately when you see displacement time, displacement distance graph, quickly remind yourself what are the info that you can get. Displacement time, is the word is time, so I know I can get amplitude, I can get period. Displacement distance, right, I get amplitude, I get wavelength, because distance, length. Okay, so this is something important. You always get these two. Displacement time, you get amplitude and period. Displacement distance, amplitude and wavelength. From displacement time, since you get period, you can find frequency, and then from there you can find V equals to F lambda. The two of these graphs together, V equals to F lambda, you will be able to find the wave speed. So what is the prefix for the factor 10 power negative 6? This one, by now all of you we already did some exercise, right, in class. You all should know your prefixes already. Okay, Okay, so your 10 power, this is 10, all these are 10, right? Okay, this one should come, if you should not be need to do like what I'm doing now. Okay, but those who cannot, you may still need to write it out. Okay, but if not, by now you should see I know 10 power negative 6, this is my micro. Okay, so what is the prefix? Is a micro. Can state the amplitude of the wave. Amplitude, both of this is 5, but you need the units. What is the units? 5 is not enough, you must state the units. You can say that it is 10 power negative 6 meters, so it's 5 micrometer, 5.0 micrometers. Okay, so either you say this or you say 5.0 times 10 power negative 6 meters. Both can. Find the wavelength of the wave. The wavelength of the wave. So where's the wavelength? We know that I need to look at the displacement distance graph. So I'm looking at this graph here. So since the wavelength is, this is 10, 1 2 3 4 5, this is 8 6 4 2, so my wavelength is 4 cm, right? 4.0 cm. Find the period of the wave. The period, it says 40, 1 2 3 4, 40 times 10 power negative 6 seconds, 1 2 3 4, so this one is 30, 20, 10, so it's 10. Either you say 10 microseconds or you say 10 times 10 negative 6 seconds. Okay, should come very quickly for you. Find the speed of the wave. This is v equals to f lambda. Okay, I don't have f, so I can take f is 1 over t. So okay, v equals to lambda over t. Do I have lambda? I do have lambda. Lambda is 4.0 cm, and remember we always want to change to SI unit. Okay, so either we take 4.0 cm or you can so from here you take 0.040 meters, and then period, this is 10 power 10 negative 6. Yeah. Okay. Seconds. Already in SI units. Correct? So no issue. Okay. So your answer, lambda 0.040 divided by 10 power 10 negative 10 times 10 negative 6. So your answer should be 4.0 times 10 power 4 meter per second. Can you answer in this case? They never give you the units, so it's easy for you can put 4.0 times 10 negative 4. But if let's say the units are cm per second, you still can, you don't have to convert this, you don't have to convert here. You can actually also give you 4.0 divided by 10 times 10 negative 6, and you get 4.0 times 10 6 power 6 cm per second. So both are fine. Okay, explain what is a longitudinal wave. Longitudinal, when you see the word longitudinal, the thing that ding 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 should come into your mind is the word parallel. If you see the word transverse, that immediately your mind must associate, your brain should immediately associate to the word perpendicular. Okay, this is very important, must immediately associate. So longitudinal, parallel; transverse, perpendicular. So are you going to answer? Explain what is meant as a longitudinal wave. Longitudinal waves are waves that, okay, so basically just waves, longitudinal waves are waves whereby the particles oscillate or vibrate parallel to the direction of wave travel, or travels in the direction parallel to its direction of vibration. Both are fine. Okay, oscillates parallel to the direction of wave travel, or like the answer says, that the travels in a direction that is parallel to its direction of vibration. So both gives the same answer. I'm saying the word that I'm looking for is here is parallel. Okay. Determine the wavelength of the sound wave. Okay, figure 3.1 shows the instantaneous positions of particle when the sound wave passes through it. It puts here, so the next is here. So you can see this is halfway, so this is probably the next half, another 2 meters. Okay, so determine the wavelength is 4.0 meters. Okay, remember 2SF. 2SF. Given that the speed of the sound wave is 330, calculate the frequency. So this one, V equals to F lambda. F equals to V, or you can, let's fill in the values first. 330, this is V, right? V equals to 330 meter per second. Lambda is 4.0 meters. So 330 equals to F times 4.0. F is equals to 330. 4.0, you'll get 82.5 hertz. Okay. Draw the pressure distance graph. So we know that highest air pressure, this is highest, this is lowest, highest, lowest, highest, lowest, highest. So high, low, high, low, high, low, high, right? And it's every 2 meters, right? This is 2 meters. So you know that if this is the highest, this is the lowest, right? It should look something like that. Yeah. Can you please use a ruler? I'm using my iPad, so I can't really use a ruler. But you all can use a ruler. Please. Something like this, right? High, high, low, high, low, high, low, high, high, low, high, low, high, low, high. Okay, so one more. Can something like this. Okay, then you can erase all the dotted lines. You should have your rulers with you. You should be able to draw to some precision. Oh. Okay. Besides wavelength, okay, then EM fraction. So premise, we know that we are looking at EM waves. Okay, shows the different regions of the EM waves. This should be in capital letters. In order of increasing wavelength. So this one you already know, You know that increasing frequency here, Increasing wavelength here. This also, we have done many exercises and we have made many mnemonics in order for us to memorize this. Alright, so increasing wavelengths, so you know that this should be the G area and this should be the R area. Oh, increasing wavelengths, but this is decreasing. Okay, so it's increasing this way. So you need to look at the values. Okay, so this is the G area, this is your R area. So we know that this is gamma. This S here is visible light, and R is your radio waves. So besides wavelength, say one difference between the waves between region R and S. So that one is frequency lah. Other than wavelength is frequency. So you must say that R, if wavelength increases this way, frequency increases this way. Okay, so R has lower frequency than S. State the speed 3.0 times 10 power 8 meter per second. Please don't forget the units. State 1 application is the wave in T gamma ray. Wow, gamma ray, so many things. We talk about radiation therapy in treating cancer, right? Radiation therapy, we also use it to check defects, right? We use it to check defects. So many things that we have written down. So one of the most common one is radiation therapy. State the order of magnitude of the diameter of a typical atom. Name the region of the electromagnetic spectrum that has a wavelength of the same order of magnitude. Typical atom, this one is go back to chapter 01. Chapter 1, remember we already said that 10 power negative 10. I just remember 10 10 10 10 10 10 10 10 10 10 10 10 10 10 10 10 10. Yeah. Okay, so typical atom 10 power negative 10. Okay, so this one, just go back here. Which one does it fall? This is 10 power negative 10. This is because this is 10 power negative 9, 0.1, so that's 10 power negative 10. So it's already it's X-ray. Okay. Describe how the sound wave electric scooter is fitted with an alarm system, which is triggered by motion. In addition to it emitting a loud sounding alarm at the scooter, it will also send out the current GPS, global positioning system, coordinates of the scooter. Describe how the sound waves from the alarm reaches the eardrums of a person near the scooter. Okay, how eardrums? Okay, we know sound waves, they are longitudinal. We know longitudinal, we know that they must mention that they vibrate parallel, right? And also when we talk about longitudinal waves, we say they create rarefactions and compressions, regions of compressions and rarefactions. So we need to say that the alarm causes vibrations of air particles. Okay, so this is the alarm, right? Ding, 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 ding. And then this is the person's ear, right? So they vibrate of the air, in between is air, right? So alarm causes vibrations of air particles producing regions of compressions and rarefactions that transfer energy to the eardrums via sound waves. Okay, so you must mention that from the ear, air, compressions and refractions, these are your sound waves, right? And then it causes you to hear because of the energy transfer. In the event of the alarm trigger, the GPS coordinate is being sent to the owner via satellite in the form of microwaves as shown. The drawing is not to scale. Microwaves are used instead of sound waves for the transmission of GPS coordinate to and from the satellite in space. State 2 reasons why microwaves are used instead on sound waves. Number 1, because this one you have to think about it. Microwaves travel at 3.0 times 10^8 meter per second, whereas sound waves 330. So one big reason is that microwaves travel much faster than sound waves. Number 2, you can see there's in space and atmosphere. We know space is a vacuum, so we know that microwaves can travel in vacuum. Whereas sound waves can't. Okay, next one. Satellite is 36,000 kilometers above the Earth's surface. Calculate the least time taken for the microwave. Least time taken to be transmitted from the smart lock to the owner. So smart lock is here, right? To the owner is here, right? So we know that there is 2D, right? This is distance, right? We know speed is equals to 2 distance over time. So we know that the speed here is, we are looking at microwave, so 3.0 times 10^8 meter per second equals to 2 times 36,000 divided by time. Right, so you will get 0. So your time equals to 2 times 36,000 divided by 3.0 times 10^8. Okay, so this is 0.24 seconds. Don't forget your units. Okay, we're about to finish. Okay, the average temperature in the day is 30 degrees. During prolonged riding on the screen, the battery tends to get overheated to 40 degrees, and this drains the power supply. To prevent overheating, engineers studied the current battery design and came out with an improve. So one is white plastic casing, the other one is aluminium casing painted black. Number 1, there are 2 things that we can see there's a different. One is white, one is black. Again, TACT. So we know that it's going to be here. Then plastic and aluminium, this is metal, right? So we are going to talk about conduction. So 2 changes here. One is they change the color, so we know that it's radiation. The other one is they change the material, so now we know that we're going to talk about conduction, right? External casing is made of white plastic while improved aluminium and is painted black. Okay, explain why the improvement in design helps to reduce the chance of overheating. The external casing painted black instead of white. We know that black is a better, cause this is hotter, right? Hot, right? So we know that it's hotter than the surrounding, so it's an emitter. So black is a better emitter of thermal radiation than white color, hence rate of thermal emission of thermal initiation of radiation is higher. There. This is your reason. This is your outcome. External casing is made of aluminium instead of plastic. Aluminium, we know the reason is aluminium is a better conductor, right? Aluminium is a better thermal conductor than plastic. So that the outcome is the rate of thermal conduction of energy from the battery to the casing is higher. Okay, so both prevents overheating. Can, and that's it. Okay, so you can see that thermal, your out of the 4 topics that you have, which is thermal processes, GWP, sound and EM waves. Usually thermal processes and EM waves are 2 topics which are easier for you to score. And so half of the topics are already easier for you to score. The other half requires a bit more mastery in actually understanding. But once you get used to it, you will see that it is quite standard. Right, GWP, quite a few things, it's quite a big chapter for you to look at. But you can actually see that it is quite strategic, right? Right, you go back to the same transverse versus longitudinal, and then you must understand the graphs, and know the calculations, how to do the calculations, and you will see that this it is not as difficult as it seems. Okay, so use the remaining time and please come up with your notes for you to prepare for your GA1s. Okay, thank you very much everybody. Have a great week.